Ollama and vLLM both serve local language models, but the numbers behind them tell two very different stories. The headline single user gap between them is small, about 62 tokens per second versus 71, but that number hides a 6L6 gap that opens up the moment real users show up. By the end of this video, you'll know exactly which one you should actually be running. Both engines are free and open source. Ollama is MIT licensed, vLLM is Apache 2.0. But the real cost split shows up once you start using either one seriously. Ollama Cloud charges $0 for one concurrent model, $20 a month for 3, and $100 a month for 10. vLLM doesn't sell hosting at all, you run it on your own GPU. Self-hosted, vLLM costs about 0.07 per million output tokens at full utilization, up to 0.45 if your GPU sits idle a lot. Run the math at 500 million output tokens a month on a fully utilized H100, and vLLM costs around $35. Ollama's comparable max tier runs $100 a month. vLLM wins this test. That's a tie on paper. That's vLLM 1, Ollama 0. My name is Brian and I review AI software, so you don't have to. Here's something that should worry anyone assuming quality is just about the model you pick. A peer-reviewed study found the inference engine itself can shift benchmark scores by up to 16.6 percentage points. Ollama's default repetition penalty of 1.1 dropped DeepSeek R17B from 78.47 down to 61.87 on the same hardware. But that hidden penalty is a real variable worth tuning if you're on Ollama. This test is a tie. Raw model quality is a tie, it depends on what you load, not which engine runs it. vLLM 1, Ollama 0, 1 tie. This is where the story most people believe falls apart. On a single RTX 4090, Ollama runs about 62 tokens per second, vLLM runs about 71. But add real users, and continuous batching changes everything. At 50 concurrent users, Ollama drops to roughly 155 tokens per second, while vLLM climbs to around 920. On an A100 running Ollama 3.18b, Red Hat's testing showed vLLM hitting 793 tokens per second at peak against Ollama's 41. Latency tells the same story. P99 latency at peak comes in around 80 milliseconds for vLLM versus 673 milliseconds for Ollama. Single user speed barely matters. Concurrent speed is the whole ballgame, and vLLM wins it decisively. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. vLLM 2, Ollama 0, 1 tie. That's a 13% gap, barely worth mentioning if you're the only person using the model. Stick with me because the last 4 tests are where this decision actually flips. Ollama flips the scoreboard here. One command installs it, one more line, and you're running a model. Under 5 minutes according to official docs. It manages models like Docker images and handles context length automatically based on your VRAM. vLLM is a Python library first. You're installing it with pip, then hand-tuning flags like max model length and GPU memory utilization before you get a working server. Ollama takes this one clean. vLLM 2, Ollama 1, 1 tie. That's a real barrier if you're not already comfortable owning GPU configuration. Ollama runs natively on Windows, macOS, and Linux. vLLM has no native Windows support. You need WSL. Ollama also handles CPU-only inference well, getting 8 to 14 tokens per second on a Ryzen 9 with no GPU at all. But vLLM's hardware reach is wider once you're outside a laptop. It supports NVIDIA, AMD, Google TPU, AWS Neuron, Huawei Ascend, and more, well beyond Ollama's NVIDIA, AMD, and Apple Metal coverage. For anyone deploying across a fleet of mixed accelerators, that range matters more than a Windows installer. vLLM takes this test. Final score: vLLM 3, Ollama 1, 1 tie. Ollama's whole identity is speed to a working model, one-line install, native support on every major OS, and CPU-only inference that's actually usable on a Ryzen 9, with no GPU involved. vLLM's identity is what happens once real traffic shows up. 793 tokens per second against Ollama's 41 on the same A100, P99 latency of 80 milliseconds instead of 673, and a self-hosted cost of roughly 0.07 per million output tokens once your GPU is actually busy. vLLM wins the scoreboard 3 tests to 1 with a tie, and the reason is concurrency. The moment more than a handful of people hit the same model at once, vLLM's continuous batching turns into a 5 to 20x speed advantage that Ollama's sequential processing simply can't match. If you're building a service for a team running 10 or more concurrent users on NVIDIA or AMD hardware, vLLM is the only sane choice here. If you're a solo developer or hobbyist who just wants a model answering questions on your own laptop in under 5 minutes, Ollama is still the better daily driver, and that's not a consolation prize. It's the correct tool for that job. Given zero extra context, my default pick is Ollama. The decisive reason most people watching this searched because they want to run something locally on their own machine, not operate a fleet of GPUs for other people. And that's exactly the job Ollama was built for. Marketing around Ollama likes to imply it's basically as fast as vLLM for local use, and the headline numbers back that up, about 62. If this helped, the next breakdown on the channel goes even deeper.